Learning advice often turns discomfort into proof. If a method feels difficult, the story says it must be building stronger learning. If performance drops, hidden progress must be happening. If a course is confusing, perhaps confusion is the price of rigor. That is not what desirable difficulty means. Some learning conditions reduce immediate fluency while improving later retention or transfer under appropriate conditions. Spacing makes a later return less supported by recency. Retrieval removes the visible answer. Interleaving removes the category heading. Generation and self-explanation remove the finished connection. Each difficulty asks the learner to perform a specific operation. Bjork and Bjork used the desirable difficulties framework to discuss conditions like these. Soderstrom and Bjork's 2015 review developed the larger distinction between learning and performance. Conditions that improve performance during acquisition do not always produce durable learning, while some conditions that make practice look worse can support later outcomes. That finding is important because easy performance can be deceptive. It does not reverse into a new rule that bad performance proves learning. Immediate struggle can reflect productive retrieval, but it can also reflect overload, missing prerequisites, inaccessible instructions, absent feedback, or a task that is simply mismatched to the learner. Compare two experiences. In the first, you close a source and attempt to retrieve one central relationship. The answer is difficult to produce, but you can check it and correct the gap. The difficulty has a job: practice access under conditions closer to later use. In the second, the source uses a blurry font, hides a necessary definition, and splits the example across several screens. Reading is harder, but the friction does not practice a future ability. The free 7-day recall experiment is linked below. It uses bounded difficulty. The source closes briefly, the answer is checked, and the idea returns later. Run a difficulty audit with 4 questions. First, what later ability is this difficulty supposed to improve? Name the outcome precisely. Recall a principle, distinguish 2 cases, explain a relationship, or perform a step. Make learning harder is not an outcome. Second, what useful processing does the difficulty trigger? Retrieval practices access. Interleaving can practice selection. Spacing changes the temporal conditions of access. A worked problem with one missing step can require the learner to reconstruct a relationship. If the answer is only more effort, the design has not explained itself. Third, can the learner succeed with effort and receive accurate feedback? A challenge that produces only guessing has weak instructional value. A learner needs enough prior knowledge to attempt the operation and a reliable way to compare the result. Productive difficulty has a correction path. Fourth, what later evidence will show whether the difficulty earned its place? Do not judge only by the feeling during practice. Use delayed recall, a new but related case, an explanation produced without the source, or actual performance with feedback. The measure should match the future ability named in the first question. Consider a statistics problem given before the learner understands the notation. The learner searches randomly and fails. That is not automatically desirable. A clear worked example may be needed first. Later, removing the method label and asking the learner to choose between 2 nearby procedures can create a useful difficulty because selection is part of the future task. Or consider a password-protected, badly formatted PDF. It takes longer to navigate and makes concentration harder. Unless navigating broken documents is the target skill, the friction has borrowed the language of rigor without identifying a learning process. Remove it. Difficulty also needs to remain proportional. A small retrieval gap can reveal what is accessible. Asking for every minor detail can turn practice into noise. A spaced return can test durability. A gap so long that all structure has disappeared may force complete relearning. Mixed cases can sharpen discrimination. Mixing before categories have meaning can create guessing. A useful difficulty often removes one support at a time. Close the answer but keep the question clear. Remove the category label but keep accurate feedback. Delay the return but preserve a route for correction. When several supports disappear together, an error becomes hard to interpret. You no longer know whether the problem was memory, comprehension, selection, or presentation. The delayed measure should match the claim. If the promised benefit is retention, test after time. If it is transfer, use a genuinely related new case. If it is execution, observe execution with the right tools and safeguards. A method should not claim durable learning from a harder practice session while never measuring what happened later. Good design makes the cause of the challenge legible. Immediate performance is still information. Repeated failure may indicate that the first model needs repair, the unit is too large, or the support faded too early. Do not celebrate every error as hidden progress. Change the design when the evidence says the current challenge is not serving its intended job. Keep the larger boundary. Better recall is not mastery. A productive learning difficulty cannot replace real performance, feedback, current references, or supervision when the task demands them. It can improve one component of preparation while leaving other components untouched. For the complete system and its evidence boundaries, see the evidence-based learner. Difficulty is a design choice, not a virtue. Ask what it practices, how the answer is corrected, and what later result will count. If it cannot answer those questions, it has not earned its place.